Today we're going to talk about converting polar and rectangular equations. Since the polar axis coincides with the x-axis and the pole coincides with the origin, a relationship can be established between the polar coordinates and the rectangular coordinates for a point. So we've already talked about these conversions and these equations already, but these are the ones that we're going to be using again. So we know r squared equals x squared plus y squared. So cosine theta equals x over r, so that's where we got x equals r cosine theta, y equals r sine theta, and the other equation we use is tangent of theta equals y over x. So these are the equations that we're going to help go from one form to the other. So looking at the first one, we've already done some of this conversions already, so that should be familiar. Here we have r equals 7. So we know that this is a circle with the distance from the pole being a distance of 7. And so for this, we just need to figure out now the rectangular equation. So if I have r equals 7, I know that if I were to square both sides, that would help me use this equation right here. So if I square here and here, I get r squared equals 49, and then I can replace r squared with x squared plus y squared. And so again, we know that this is a circle, and we know the center is at 0, 0, and that the radius is the square root of 49, or in this case, the radius is equal to 7. Looking at the next one, now we have theta equals pi over 4. So for this one, we're going to use this tangent theta equals y over x, and we're going to put pi over 4 in for theta. So we have the tangent of pi over 4 equals y over x. On our unit circle, the tangent of pi over 4 in the first quadrant is 1. And we're going to solve, this is the line for y equals, so y equals 1x, or just x. And of course, this is the equation for a line that goes through the origin. Next, we have r sine theta equals 5. So we can use this equation right here. R sine theta is equal to y, so we get y equals 5, and this is a horizontal line. Next, we have 12 equals r cosine theta. So r cosine theta is, of course, equal to x. So we get 12 equals x, which is a vertical line. So those are some of the easier ones, but they do get more complicated. So next we have r equals 3 cosecant of theta. So cosecant, we know, is a reciprocal function for sine. So instead of using cosecant, we'll use sine. So r equals 3, and cosecant's 1 over the sine of theta. And the reason we like doing that, because then we can multiply both sides by the sine of theta to get it out of the denominator. So that gives us r sine theta equals 3. And we know then r sine theta is y. So y equals 3, which is a horizontal line. Over here, we have r equals 10 cosine theta. So for this one, if I square both sides, that means I would be squaring this and squaring all of this. That doesn't help me get rid of the cosine. So instead of squaring both sides here, I would notice that in order to get rid of the cosine, I need it to be r cosine. So I'm going to multiply both sides by r. So that gives me r squared equals 10 r cosine theta. And r squared is x squared plus y squared equals, and then r cosine theta is x, so 10x. Now, because I have a quadratic term for x and for y, and the numbers in front are the same, I know this is going to be a circle. So we're going to complete the square by taking the 10x to the other side. I'm going to add something to complete the square and then subtract it so it doesn't change the equation. We don't need to complete the square for the y because there's no linear term. So remember, the number that completes the square is half your linear term squared. So half of negative 10 is negative 5, and negative 5 squared is 25. So this gives me x minus 5 squared plus y squared. I'm going to take the negative 25 and add it to the other side. So this is the equation of my circle. So this is the circle. And we know the center is at 5, 0. And the radius equals 5. All right, for the next one, so same issue here is that I don't have an r with the cosine theta and sine theta, so I'm going to multiply both sides by r to get r squared equals, and then because I'm multiplying both sides, I have to multiply everything by that r, so 8r cosine theta plus 4r sine theta. That then gives me x squared plus y squared equals 8x plus 4y. Again, my quadratic terms don't have any numbers in front, or it was just 1 for the coefficient, so it's the same. So we know, again, this is going to be a circle. So I'm going to subtract the 8x and the 4y to the other side. I'm going to complete the square for both x and y now. And remember, if there was numbers in front of your quadratic term, then you would want to factor that out before you complete the square. So for the first one, to x's, we have a linear term of negative 8. Half of negative 8 is negative 4, and negative 4 squared is 16. So that completes the square for x's. For my y's, half my linear term is 2. And then 2 squared is 4. So the number that completes the square for the y's is 4. So then this becomes x minus 4 squared minus the 16 plus y plus 2 squared minus the 4 equals the 0. And then, of course, we want to take that 16 and the 4 to the other side. So x minus 4 squared plus y plus 2 squared. You know what? And I just realized that it's positive 4. This should have been minus 4y because we're taking this to the other side. So this should be minus, sorry. And this should be minus. Okay. And that is equal to 16 plus 4 is 20. So this is the equation of my circle. And the center is at 4, 2. And the radius is equal to the square root of 20, which is equal to root 5 when you reduce. Looking at the last equation, so for this one, I have 1 minus cosine theta in my denominator. So I can't just use a reciprocal function because of the 1 minus cosine theta. So I'm going to multiply both sides by 1 minus cosine theta just to get it out of the denominator. So then that's going to distribute the r. So I get r minus r cosine theta equals 4. So then once I have that, then again, I know that I can change r cosine theta into x. So I get r minus x equals 4. And I can also take the r, and remember, we know r squared equals x squared plus y squared. So I can replace that with the square root. So this would be the square root of x squared plus y squared equals, or minus x equals 4. And I'm going to add the x to the other side. It's the x plus 4. And the reason I did that is because, again, I see that this is going to be, I have an x squared and a y squared, but I'm taking the square root. So I'm going to get rid of this, and I'm going to figure out what type of, equation this is going to be. So by squaring both sides now, I get, and I might think it's a circle, but it's actually not going to be a circle. So this is x squared plus y squared equals, and then here, remember, this is x plus 4 times x plus 4. You need to FOIL that out. So if we were to FOIL this out, we would get x squared plus 4x plus 4x plus 16. So this becomes x squared plus 8x plus 16. And so, like I said, it looks like it'd be the equation of circle, but when you combine your like terms, notice that this x squared quadratic term is going to cancel out. So I'm left with y squared equals 8x plus 16. This tells me that I have the equation for a parabola, because notice that you only have one quadratic term here. And this is actually a parabola that's going to open, looks like, to the right. So it means we're going to solve for the x. Oops. So it means we're going to solve for the x. And when we do that, we would get y squared minus 16 equals 8x. And then, of course, we have to divide each term by 8. So that gives us x equals 1/8 y squared minus 2. And this, of course, again, is the equation of parabola. It opens right. And the vertex looks like it's at, remember, this is your h, and your k is with your y when it's x equals. So the vertex would be -2, 0. So let's go ahead and look at this on our graphing calculator. If we go to mode and put this in polar mode, and we're on radian as well, and go to my y equals, and now notice it has r. So 4 divided by 1 minus cosine theta. And if I then hit graph, you can see it's a sideways parabola with the vertex at -2, 0. So if we were to find the focus, remember we use 1 over a equals 1 over 4p. So then 4p equals 8, so p is equal to 2. So that means that 2 to the right from the vertex would be the focus, which would, in this case, if you're looking here, be at 0, 0. So remember that focal width or lattice rectum is 1 over the a value. So 1 over 1/8 means it's a distance of 8. So you can even count here 1, 2, 3, 4, 5, 6, 7, 8 for that focal width on our calculator as well. So that's for the parabola. So again, you have to be careful because, again, we might have thought it was a circle at first, but it ended up being a parabola in the end. So that's how we convert from polar equations to rectangular using these equations up here. And we're going to do the same thing, except for now we're going to convert from rectangular to polar, which is sometimes harder. So when you're converting rectangular equations to polar equations, you want to make sure you have it as set as r equals. So we want r equals for our equation. So if I have x equals 8, so we know those conversions. X is equal to r cosine theta. So that means we can take out the x here and replace it with r cosine theta equals 8. And then the next step would be to set it, solve for r. So r equals 8 over cosine theta would be our equation. You could also use your reciprocal functions as well. Remember that 1 over the cosine of theta is equal to the secant of theta. So we could also write this as r equals 8 secant theta. It would be the same thing. So it doesn't matter how you want to write it. Looking at question number 2, for this one, I have an x and a y. So remember, y is equal to r sine theta. So we're going to take out the x and replace it with r cosine theta. And take out the y and replace it with r sine theta. And remember, we're trying to solve for r equals, and we have r in both of these equations. So you're going to need to factor that out and put it on the outside. So this becomes 5 cosine theta plus 4 sine theta equals 8. And then again, the next step is to solve for r. So r equals 8, and this is all being multiplied, so we're going to divide that. So 5 cosine theta plus 4 sine theta. Looking at the next one, we have x squared plus y squared equals 16. So we know this is the equation of a circle. So for this one, x squared plus y squared we know is equal to r squared. And remember, we're trying to solve for r. So when we take the square root of both sides, we get r is equal to 4, or you could use r equals -4, either or. Looking at the next one, we have y equals 4. So this would be r sine theta equals 4. So r equals 4 over sine theta. And again, you could use a reciprocal function. We know 1 over the sine of theta equals the cosecant of theta. So we could also say r equals 4 cosecant theta. All right, question number 5. So for this one, the first thing I would do is FOIL out the x minus 3 squared, because remember that's really x minus 3 times x minus 3. So if you FOIL that, you get x squared minus 6x plus 9. And then I would then notice that I have x squared and y squared. So I'm going to highlight that. So I have x squared and y squared. And we know that x squared plus y squared is equal to r squared. Then I would notice that if I subtract the 9 to the other side, those 9s cancel out. And we know x equals r cosine theta. And again, I'm trying to get r by itself. So the next thing that I would do is I would factor out r here. And when you do that, you actually have two equations that you're solving. So if we solve this, we get r equals 0 and r minus 6 cosine theta equals 0. Well, r equals 0 we're not going to use because this is the equation of a circle, right? So this is a circle. And the center of our circle is at 3, 0 with a radius of 3. So r equals 0 would be at the pole or the origin. That's not actually a part of our graph, so we don't actually use that for our answer. So the next step would then just be solving this equation for r. So r is equal to, if we add this to the other side, 6 cosine theta. And it's kind of like, if you remember, when we multiplied both sides by r in order to get the r here. That's what's happening when you're getting rid of it over here. So let's see if we had one of those. Yeah, so like this number here, number 6, when we multiply both sides by r in order to go ahead and be able to get the r squared and the r cosine theta. So it didn't change the equation, but because we're doing it to both sides, but it introduced an extra r. It's kind of the same idea down here, which is why we don't need that one. So looking at the next one, same thing. So y squared is r sine theta equals y. So this would be squared. And then our cosine theta is x. So this would be r squared, and sine squared theta equals 4r cosine theta. So what we could do is we could set this equal to 0 and factor out the r. So this would be r squared sine squared theta minus 4r cosine theta equals 0. So this would be r times r sine theta, sine squared theta, minus 4 cosine theta equals 0. So then we get r equals 0, which we don't use. And then r sine squared theta minus 4 cosine theta equals 0. Again, we're just solving for r. So r sine squared theta equals, add the 4 cosine theta to the other side. And then we're trying to get r by itself, so we're going to divide both sides by sine squared theta. So r equals 4 cosine theta over sine squared theta. That's one way we can write our answer. We could also write this as 4 cosine theta over sine theta sine theta. And remember, cosine over sine is cotangent. So this would be r equals 4 cotangent theta, and then this would be 1 over sine theta. And remember, 1 over sine is cosecant theta. So we could also write that like this. I'm assuming most of you are just going to write it the first way, which is fine, but sometimes we can see it this way. Another way we could have done this problem up here is you can also divide out the r for this when you're solving. So this would be r squared sine squared theta minus 4r cosine theta equals 0. So if you divide up the r, that gives us the same thing. As what we have right here. It's just a good habit usually to get into factoring it out because it'll help you when you get into BC calculus or into calculus. Looking at question number 7. So for this one, we have an x and a y. So you could replace this with r. So r sine theta equals root 3, and this would be r cosine theta. And then if you divide by r cosine theta, r over r cancels out, and notice you have sine over cosine. And sine over cosine is tangent. And so then you just need to figure out where do you get root 3 on your unit circle for tangent. So thinking about your unit circle, that would be right up here. We get root 3 for tangent. Remember, this one down here is root 3 over 3, and this tangent of pi over 4 is 1, so pi over 3. Another thing you could have noticed for this one is that if you just divide the x and the y, you get y over x equals root 3. And again, we know the tangent of theta equals y over x. So you could have just taken out the y over x and wrote the tangent of theta from there equals root 3. But notice you get the same thing in the end regardless of how you do it. So you can still write r cosine theta and r sine theta, and your r's end up, like I said, r over r is just 1, so that cancels out. But it's just another way of doing the problem. And that is all for our converting from polar to rectangular and rectangular to polar.